Unit 9.5 is inscribed angles. Inscribed angles. An inscribed angle is an angle. Figured that, didn't you? An inscribed angle is an angle whose vertex is on the circle, whose vertex is a point on the circle, and whose sides are chords of the circle. An inscribed angle is an angle whose vertex is a point on the circle and whose sides are chords of the circle. So we take a point on the circle, make the sides chords of the circle, we have an inscribed angle. The vertex is on the circle. Theorem 9.5 says the measure of an inscribed angle is half the measure of its intercepted arc. So that angle there intercepts this arc. The arc is 70, so the angle is half that, 35 degrees. I sneezed, but I paused. I made it. Excuse me. And so an inscribed angle is an angle whose vertex is a point on the circle and whose sides are chords of the circle. An inscribed angle is equal to half the measure of its intercepted arc. And what we put in the chart was, if the vertex is on the circle, the angle's half the arc. If the vertex is the center, the angle is equal to the arc. Okay? So, let's clean this up a little bit. Inscribed angle, we're on example 1 here. Inscribed angle, angle ABC, is equal to half the measure of its intercepted arc, arc AC. Therefore, angle ABC is 1/2 of 70 degrees, which makes it 35 degrees. Number 2, inscribed angle, angle BCD, is equal to 1/2 the measure of its intercepted arc, arc BD. Therefore, angle BCD is half of 80, which is 40 degrees. Number 3, inscribed angle, angle CDE, intercepts arc CE. It's going to be 1/2 the measure of its intercepted arc, arc CE. So angle CDE is 1/2 of 90 degrees, which is 45 degrees. An inscribed angle is an angle whose vertex is a point on the circle and whose sides are chords of the circle. The measure of an inscribed angle is equal to 1/2 the measure of its intercepted arc. And then we have corollaries for Theorem 9.5, things that we can conclude quickly because we know about inscribed angles. If two inscribed angles intercept the same arc, they're going to be equal. Example, let's say we got this arc out here. If angle 1 intercepts that arc, angle 1 is an inscribed angle that intercepts that arc, so angle 1's half of that arc. Well, angle 2 is an inscribed angle that intercepts that same arc, so angle 2 is half of that arc. So if angle 1's half of that arc and angle 2's half of that arc, then angle 1 and angle 2 must be equal. If two inscribed angles intercept the same arc, then those two angles are equal. Corollary 2. An angle inscribed in a semicircle is a right angle. Why? Well, a semicircle is 180. An inscribed angle is half the arc. Half of 180 is 90. And a right angle is 90. If we draw a semicircle, notice that if you try to inscribe an angle in it, go from one endpoint to a point on the circle back to the other endpoint, it's going to be 90. You could try it again from this endpoint to a point on the circle back to the other endpoint, 90 again. No matter how you do it, it's going to be 90 degrees. Why? Because look what they're intercepting. The arc that they're intercepting is the other semicircle, which is 180 degrees. They're inscribed angles, so they're going to be half of that, which is 90. Corollary 3. If a quadrilateral, that's a four-sided figure, is inscribed in a circle, then its opposite angles are supplementary. Well, why would that be? Well, let's look at the opposite angles. Angle 2 is this angle. Its measure is half of the arc that it hits. It's half of that arc. The angle opposite angle 2 is angle 4. The arc that it intercepts is the rest of the circle. Now, if 2 is half of what it hits, and 4 is half of what it hits, and together they hit the whole circle, then their angles together is going to be half of the whole circle, which is 180, and two angles whose measures have the sum of 180 are said to be supplementary. So if a quadrilateral is inscribed in a circle, then opposite angles are supplementary. Okay? So we have a rule, a theorem about inscribed angles. An inscribed angle is half the measure of its intercepted arc, and three quick corollaries that come from that theorem. Theorem 9.6 says an angle formed by a chord and a tangent to a circle is half of its intercepted arc. Here we have a tangent to a circle, a line that lies in the plane of the circle and intersects the circle in a point. A chord is a segment that joins 2 points on the circle. Sorry, I'm missing. It's not going straight for me. We're actually talking about this angle here. The arc that angle intercepts is this arc. That angle in black is going to be half of the arc in green, okay? All right. Now, it says here that arc CAB, so I must have lost a letter here in the copy machine, is equal to half of arc AC. So CAB is half of 160 which means that this arc must have been labeled as 160 degrees. Therefore, that angle is 80 degrees, half of that. If you go back to the chart, remember, if the vertex is the center, it's equal to the measure of the intercepted arc. If the vertex is on the circle, whether it's inscribed or formed by a chord and a tangent, it's half the measure of the intercepted arc. Okay? So daily work 9-5. Looks like fun. This is getting more and more complex, you see, because we're learning more and more rules. We still have all the rules from the first of the year, piling up with all the rules from the last of the year, combined with all of the algebra that we've ever learned in our middle school math. So it's just kind of becoming a cumulative thing, which is why it looks so complex. Okay? So let's just answer a few questions at the front. Arc AB, arc AB is the arc of chord AB. Chord AB has one mark in it. This chord over here has one mark in it, which means those are equal chords. In the same circle or in equal circles, equal chords have equal arcs, and equal arcs have equal chords. Since the chord on the left has an arc of 80, then its equal chord on the right, AB, would also have a arc of 80. Equal chords have equal arcs. CB. Arc CB is the only thing not marked. A circle's 360 degrees. So if we add everything up but that, 80 plus 40 is 120, plus 90 is 210, plus 80 is 290. Subtract and you get 70 degrees for arc CB. A circle's 360 degrees. So far we've used equal chords have equal arcs, and we've used that a circle's 360 degrees. Angle 1 is an inscribed angle. You might say, well, where's its vertex? On the circle. If the vertex is on the circle, then it's half of the arc it hits, so the angle's half the arc, 20 degrees. Angle 2, where's the vertex? The vertex is on the circle, so it's half the arc it hits. So it's half of arc CB, so it's 35 degrees. Okay, and you can continue there. Let's look at number 17 through 22. I'm going to white things out so I can draw a little bit bigger picture of it so we can kind of see it maybe. All right, what do we got going here? Well, we've got all kinds of stuff going here. First of all, AE is a diameter. It's a diameter because it's a chord that passes through the center. That makes arc ABE a semicircle. If an angle is inscribed in a semicircle, then it's going to be a right angle. So angle ABE is 90 degrees, which means that what I have over here is a right triangle. An angle inscribed in a semicircle is a right angle. Now, it says angle CFE. Angle CFE. And what would I know about CFE? Well, these lines are parallel. The arrows are telling me that. BE is a transversal of those. If a transversal is perpendicular to one of two parallel lines, it must be perpendicular to the other. Therefore, that's a right angle also. So angle CFE is also 90 degrees. Well, what about CE? What about CE? Well, CE is a radius. We can see that in the circle over there. But we may not can solve for that yet. Let's see what's covered up here. We've got a 4 and a 4 and a 3 CE. Yeah, we can find it. Because we can use what? The Pythagorean theorem. If we use this little triangle, it's a right triangle. We know two sides, 3 and 4. We can find the third side, CE, using the Pythagorean theorem. So we're going to say C squared equal A squared plus B squared. CE is the hypotenuse C, so that square is equal to 3 squared plus 4 squared. So my hypotenuse CE squared is equal to 9 plus 16. So CE squared is equal to 25. We undo the square with the square root, and we get CE equal 5. So we've got CE is 5 by the Pythagorean theorem. What about AE? Well, there's another theorem that just popped out here. If a line is parallel to a side of a triangle, then it divides the other two sides proportionally. So top piece over bottom piece equal top piece over bottom piece. 4 over 4 equal something over 5. Well, it's got to be a 5 because 4/4 equal 5/5. So this is also 5 by the theorem about sides divided proportionally. If a line is parallel to a side of a triangle, then it divides the other two sides proportionally. So top piece over bottom piece equal top piece over bottom piece. That means that the whole thing from A to E is 5 plus 5, which is 10. Well, what about AB? Well, that's not a sides divided proportionally, but we know that angle E of that little triangle is equal to angle E of the whole big triangle. So we have two angles of the little triangle in yellow are equal to two angles of this whole big triangle. So those triangles are similar by angle-angle similarity. Or we've also proved that the sides are divided proportionally, which means we could also prove it by side angle side similarity. Now, you may say, or what? Well, how could we find AB? Well, there's two ways we could find AB right now. If we look at this whole big triangle, we've got that this is 4 plus 4, so the whole thing is 8. And this is 5 plus 5, so the whole thing is 10. So I know two sides of that, and I can find the third side with the Pythagorean theorem. So I could just let that be A, and I could go C squared equal A squared plus B squared. And I could find that, right? Or I could use similar triangles and solve it. If I solve it using the Pythagorean theorem, then basically I have proved with Pythagorean theorem that all three sides are in proportion, so then I could say that they're similar by side, side, side. If we prove they're similar by angle, angle, or side, angle, side, then we could use the fact that they're similar to set up a proportion for AB, okay? Several options there, okay? So there's a lot of things going on in these pictures. We've got isosceles triangle theorem rules. We've got special right triangle rules. We've got similar triangle rules. We've got congruency. We've got all of these tangents and radiuses and arcs and chords happening, okay? Just got to kind of know geometry or you get all jammed up here, all right? Let's look at E. It's got a little bit of algebra in it. Let's just kind of play with that one. How could we find X? Well, we know that if a quadrilateral is inscribed in a circle, then opposite angles are supplementary. So angle E is supplementary to angle G. If a quadrilateral is inscribed in a circle, then opposite angles are supplementary. Supplementary angles are two angles whose measures have the sum of 180. So angle E, which is x degrees, plus angle G, which is 2x plus 3 degrees, must be equal to 180 degrees if a quadrilateral is inscribed in a circle, then opposite angles are supplementary. We're going to do anything we can to simplify in the order, please excuse my dear Aunt Sally, looking for distributive and combining like terms. Understood 1x plus 2x is 3x plus 3 equal 180. There's nothing else to do to simplify. The variable is not on both sides, so it's time to undo. We're going to undo addition by subtraction. We will get 3x is equal to 177. We're going to undo multiplication by division. And we're going to get x is equal to. So 177 divided by 3 is 59. So x is equal to 59 degrees. Angle H would be x, which is 59 plus 21, which would be 80 degrees. Angle G would be 2 times 59 plus 3, which would be 118 plus 3, which would be 121 degrees. Angle F, if angle H is 80 degrees, opposite angles are supplementary if a quadrilateral is inscribed, so angle F must be 100 degrees. Arc HF. Now, we need to think about that. Which one is it? That's what we're thinking. Which way do we go? Arc HF could either be here or here. So how do we know which one? Well, it named it with 2 letters, so it must be the less than 181. Well, which one is the less than 181? Well, let's put our measures back in. X was 59 degrees. It's an inscribed angle. It's 1/2 the measure of its intercepted arc, and it intercepts the blue. So the blue is twice that, 118 degrees. The angle at G was 121 degrees. It intercepts the red arc. It's half of the red arc, so the red arc must be twice that, 242. Now this got named with 2 letters, so it must be the minor arc, which is the one less than 180, so it's the 118 degrees. Lot to think about. Lot to think about. We've got some algebra going on now. Lots of geometry going on. Definition of minor arc and major arc going on. Okay? Any questions there? All right, so that ended what I'm going to do for daily work on 9-5.